Good evening, students. So those who have not subscribed my channel, please subscribe my channel and also share my videos. So let us start with the question number 7 and 17, which are left out questions of the exercise of chapter 12 electricity of class 10 CBSE NCERT. Okay, so let us start with the question number 7. The question number 7 says the values of current I flowing in a given resistor for corresponding values of the potential difference V across the resistor are given. Okay, so the values are given across the resistor I and V. I denotes the current and it is given in amperes. V denotes the voltage, it is given in volts. The values are given in a table form over here, and we are asked to plot a graph between the V and I and also calculate the resistance of that resistor. So we need to plot the graph first, and after that find out the value of the resistance. Okay, so let us start with the plotting of the graph. We have been already given us the values in a table form over here. Okay, so let us start plotting the graph. So taking the axes, one we will take as x-axis and the other we would be taking as the y-axis. Okay, actually the graph will be coming appropriate in a graph paper only. Here we can only plot and visualize that our positions coming like that of the values, and we can only visualize the resistance, but actual graph will be plotted on the graph paper itself. Okay, so let us mark one, 1.5, 2, 2.5, 2.5, 3, 3.5, 4, 4.5. Okay, so here we have taken our currents which are given in us in amperes. Okay, because we have to plot the VI graph. On the y-axis we are taking our voltages 2, 3, so we can take with the gap of 2, 2, 4, 0 is here, 6, 8, 10, 11, 12, 14, 16. Okay, so the first value is given to us as 0.5 and 1.6. 0.5 is here, this is our voltage in volts. Okay, so 0.5 is our current and voltage is 1.6 over there. So 0.5 is over here, 1.6 it would be 1.6 would be somewhere here. So let us mark it this point to be 0.5 comma 1.6. Okay, then the next value is 1 and 3.4. At 1 the value is 3.4. 3 would be somewhat over here, 3.4 would be somewhat over here. So I'll be getting the point over here. Okay, so we can mark it as 1 comma 3.4. Okay, then the next point is at 2 and the value of V is given as 6.7. Okay, so 2 is here, 6.7, 7 is here, so 6.7 would be before 7 itself. Okay, so here, so this would be 2 comma 6.7. Okay, then the next value is 3. At 3 the value of voltage is 10.2. 3 is here, 10.2 would be somewhere here. So it would be here. Okay. So it is 3 comma 10.2. And next point is at 4, the value is 13.2. So 4 is here, 13.2. 13 would be somewhere here, 13.2 would be somewhere here. So it would be here. Okay. So we have marked all the points. So when we will join it, we would be getting a straight line. Okay. Okay. So this is the straight line we are getting. Now between these 2 points, we will be getting R1. Between these 2 points, R2. Between these 2 points, R3. And between these 2 points, R4. Okay, and then we will be calculating the average value of the resistance. Now the resistance is given by the slope of the line. We have to calculate the resistance. So let us start calculating the resistance. Resistance is always given by the slope of the line. So we already know that how to calculate the slope. We have learned in the mathematics geometry that the slope of any line, when the 2 points are given, then the slope is equal to y2 minus y1 upon x2 minus x1. y2 are the y coordinates and the y2 and y1 are the y coordinates, and x1 and x2 are the x coordinates. So here in the place of y, we are having the voltage. So we will be writing over here v2 minus v1 upon x2 upon i2 minus i1, because in the x coordinate we are having the I, which is the current. Okay. So my R1 will be equal to v2 minus v1 upon I2, sorry, not x2. x2 is for the geometry. Here we are denoting with v and I2 minus I1. Okay. Because we already know why this is happening. Actually, we already know that V is equals to IR. Okay. We already know that V is equals to IR. So my R will be equal to V upon I. So my R will be equal to V upon I. So V2 minus V1 upon I2 minus I1 will give me the resistance value. Okay. So let us put the values. So V2 I am having from the graph, V2 I am having 3.4. So 3.4 minus 1.6 upon I2. I2 is 1 minus 0.5. So after solving it, I'll be getting from here 3.6. Okay, I'll be getting 3.6. Similar way, I'll be finding out R2. R2 will be equal to V3 minus V2 upon I3 minus I2. So V3 is 6.7 minus 3.4 upon 2 minus 1, which will be giving me 1 itself. So from here I'll be getting 3.3. Okay. And then R3, finding out the R3 will be equal to V4 minus V3 upon I4 minus I3. So V4 value is 10.2 minus 6.7 upon 3 minus 2. Okay. I4 minus I3, which is 3 minus 2. So here also, when I'll be subtracting, I'll be getting the value equal to 3.5. Okay. Yes, it is 3.5. Then R4 will be equal to V5 minus V4 upon I5 minus I4. So from here, V5 is equal to 13.2 minus 10.2 upon 4 minus 3. 4 minus 3. So this we will be getting as 3.0. Okay. So these are the values. Now we need to find out the resistance value between this point and the last point. So the resistance value, the whole resistance value should be calculated. So that resistance value will be equal to average of all the resistances. Okay, it will be given as average of all the resistances. So my resistance will be equal to 3.6 plus 3.3 plus 3.5 plus 3 upon 4. So when I'll be solving it, we'll be getting over here 3.35 ohms as our answer. Okay. So in this way, we need to calculate the value of the resistance. So now let us move on to the question number 17. Question number 17 says an electric heater of resistance 8 ohms draws 15 ampere from the service mains 2 hours. Calculate the rate at which the heat is developed in the heater. We have to calculate the rate. Actually, we have to calculate the rate. So the rate of doing work, we always say the rate of doing work is the power. So this only we need to calculate. Okay, so we need to calculate the power. Okay, and the work is nothing but the energy consumed energy is given by I square RT. So H, or we can say work in the terms, is equal to, or energy, it will be equal to I square RT. But this does not specify the rate. So we need to calculate the rate at which the heat is developed. So the rate at which the heat is developed is given by I square RT upon T, or you can also say it is power P. Okay, so TT gets cancelled, so we are left with here I square R. We have been given the current as 15 and we have been given as the resistance value as 8. So let us put equal to 15 square into 8. Okay, so we'll be getting over here 225 into 8, which will be equal to 1800 joules per second. Okay, which will be equal to joules per second. So this is our rate. This is the rate at which the heat is developed. Okay, so this is our power which we need to find out, and this is our answer. Okay, so in this manner we need to solve such type of questions. So please subscribe my channel, please share my videos, and if you have any doubt you can ask me in the comment section. Thank you.